Hello class, I'm here to explain how the Richter scale works to measure the magnitude of earthquakes, and I'm excited to do it. So the Richter scale was designed by a man named Charles Richter, and it was designed to measure magnitudes of earthquake in logarithmic exponential values with powers of 10. Um, So here, the formula for the Richard scale will be m equals log 10, where a divided by AO, where m is the earthquake's magnitude. A is the maximum amplitude of the seismic wave, and AO is the standard amplitude at a distance measured from the epicenter of the Earth's crust. Scales uses logarithmic functions, which means a tenfold increase in measured amplitude. Here's the first application using a problem in the real world with the exponential and logarithmic functions with the Richter scale. And our first problem example is an earthquake is measured with a wave amplitude of 296 times as great as AO. What is the magnitude of this earthquake using the Richter scale to the nearest tenth? R equals log times A divided by AO. Since A is 296 times as large, A equals 296 AO. So if you plug that into the equation, you just get 296. So then it would be R equals log times 296. Enter that into your scientific calculator. You hit the log button, which is located on your TI-85 calculator. If you go on the left hand side, you'll see the logarithmic button. You hit log and then you hit 296, close your parentheses and hit equal. That will give you a measurement of 2.5, which is rounded to the nearest tenth. So we can say the magnitude of the earthquake is then calculated to measure 2.5, where R is the magnitude of the earthquake. So our second application is where we're measuring sound with decibels, and you can also measure the sound of an earthquake using decibels and exponential logarithmic equations. Here is the formula and an example problem. The formula is D equals 10 log times P divided by P over O, where P equals the force of the sound and PO is the smallest sound that our ears are able to register. An example problem includes the earthquake has a noise of 60 decibels. The lightning strike that occurred simultaneously has a noise of 72 decibels. The lightning strike has a sound of how many times more great than an earthquake? Next, plug the equation 60 equals 10 log divided by H or times H divided by PO, where H is the force of the lightning strike. Divide the equation by 10 to get the log by itself. So 6 equals log times H divided by PO. Rewrite the equation as an exponential equation. So 10 to the 6th equals H divided by PO. Multiply PO to get H by itself. So H equals 10 to the 6th PO. Repeat same process to find the force of the sound for the lightning strike. So we go down more and we see that 72 equals 10 log times 10 divided by PO. So 7.2, plugging that in, 7.2 equals log times D divided by PO, which gives us 10 to the 7.2 equals D divided by PO, where D equals 10 to the 7.0 PO, where D divided by H equals 10 to the 7.2 divided by 10 to the 6th PO. So after you plug that in, you get 10 to the 1.2. So the lightning sound is 10 to the 1.2 power, or about 16 times as great as the sound of the earthquake. So if you look to the left over here, we're going to use the Richter scale to measure the magnitude of an earthquake. So the formula is R equals log times the amplitude AO divided by AO, or R equals log times A divided by AO. And in this case, the problem states an earthquake is measured with a wave amplitude of 496 times as great as AO. What is the magnitude of the earthquake using the Richter scale to the nearest tenth? So since A is the 496 times as large as AO, we're going to say A equals 496 AO. So you would plug that in, and R equals log times 496 AO divided by AO, so is 496. So if you take your scientific calculator and you enter this equation in, you would just go log times 496 equals, which gives you 2.695. So rounded to the nearest tenth, the magnitude of the earthquake is 2.7, because if you round 2.695 to the nearest tenth, you're going to get 2.7. So the magnitude of the earthquake is 2.7 using the Richter scale. So professional skills that are required for measuring earthquakes and where we use exponential and logarithmic functions is going to be a scientist that's called a seismologist, and they use what's called a seismograph to measure earthquakes, and that combined with the Richter scale will give us the full magnitude of an earthquake. Some good education and tools that you will need to have when working with a seismologist or a seismograph is going to be some algebra, and you're going to need to learn how to use logarithmic functions and exponential functions in order to keep up and understand the mathematical skills that the scientists are using to understand our weather patterns, or to prevent any catastrophes that are happening in the world. So the source on the mathematical modeling with exponential and logarithmic functions I got from LibreText Mathematics online, and if you Google that and use this URL down here that I provided, it's a bite to swallow. It's a really long URL, but you should be able to find it through that way. Down here, my second source, I used How We Measure Earthquakes. I found that on YouTube. I didn't find an author for that one, but it was uploaded by Wonder Pulse. And if you just Google in How We Measure Earthquakes and then enter in that URL that I provided right by it, you should easily find, so you can double check my sources and understand the information that we went over. I hope this lesson plan was helpful, and I hope you guys have a wonderful day. Bye! So this is the end of the lesson plan. I hope that the information was helpful and you learned a little something. Feel free to subscribe or like in the likes below, or comment on Blackboard. Have a wonderful day. Bye!